and was able to measure more energy being emitted from this planet than it receives from the sun. And that makes Jupiter kind of special. Because remember I said our planet, all of the processes on the surface of our planet are powered by the sun. But here we have a planet that is powering its own processes. So deep inside the core of Jupiter, there's something at work which is causing heat. It's making energy. That energy is heating its atmospheric gases. And what happens to a gas when it is heated? It expands. And what does it want to do when it expands? It rises up. Hot air likes to rise. It wants to climb on top of cool air. So as these hot atmospheric gases are rising up into the atmosphere, it passes the cool atmospheric gases, which are descending. And it makes these little ellipses that we see here, which are massive hurricanes. In fact, this big red spot over here is a hurricane so massive it could swallow 3 Earths sitting side by side. This big red spot, in fact, was observed by the first astronomer ever to view Jupiter through a telescope. Can anybody name the astronomer who was the first astronomer to view the sky with a telescope? How about it? What was it? Galileo. Excellent. Galileo viewed all of these features and documented them in his notebook. And can anybody tell me what he named this feature? In fact, it's the same name that astronomers still use to identify that feature on Jupiter. So what is that called?
The eye.
The eye. Nope, not the eye.
Big spot.
The big spot, that's right, the big red spot. So Galileo, as I said, was the first to identify some features around Jupiter. And it's also famous for another feature. What is the other thing that Jupiter is really famous for in addition to its big red spot? The one who said it loudest is most correct, that's right. It's moons, that's right. In fact, Jupiter has 65 moons orbiting around it. And we're going to explore all of them. No, we're not. But we are going to explore one that is very special to us here at the Ames Research Center. The moon Europa. Europa is a solid surface moon, very much like many of the other solid surfaces that we've been exploring so far. But we see this surface has something missing from it that the other solid surfaces we've been exploring doesn't have. Can anybody craters? That's right. This object doesn't have craters, and that's kind of weird. Because everything else that's solid in our solar system is covered with potholes. What we do see, however, is that it's very, very bright, and it has all of these cracks coming around it. Europa is covered by a giant water-ice glacial surface. And as it swings around giant Jupiter, the tensional forces to Jupiter's gravity drags the surface crust towards the planet. And when it whips around to the other side of Jupiter, the tensional forces drive the surface crust in the other direction. So when a solid, icy surface is dragged across a rigid, rocky subsurface, what do you think you get? What happens when two solid surfaces rub against each other? Not earthquakes. You get friction, which causes heat. And what happens when you heat ice? I'm sorry, they got it faster. Ice melts. It makes water. And beneath the surface crust of Europa is a layer of flowing liquid water. And here on Earth, any place where we find flowing liquid water, we find life. And so Europa is our best place to look if we ever want to find aliens outside of planet Earth. So now we're going to leave Europa and its gas giant Jupiter and head out to the next planet in the solar system, which is not Uranus, although that is the funnest planet, the funnest name in the solar system. I'm hearing like it being mumbled out there. Come on, in the back row, what's the next planet we're going to? No, not Mercury. We already went to Mercury. Thank you. Okay, Saturn. Saturn is the farthest object that we can see in the nighttime sky without the aid of a telescope. In fact, Saturn has been observed by astronomers going all the way back to antiquity. And the reason we can see Saturn from so far away is because it's surrounded by this very bright reflective ring. In fact, the ring is so big, if you were to park Saturn next to the Earth, the ring would span all the way from the surface of our planet 240,000 miles away to touch the surface of the moon. However, the ring is also very thin. And if you approach Saturn from the equator, you see that the ring gets thinner and thinner and thinner and thinner until it practically disappears. You see, the ring is only about 10 meters thick. To put it another way, if you were to park Saturn next to planet Earth, the rings would fit inside this tent. So back in 2004, the Cassini spacecraft, actually, came in a little close there. The Cassini spacecraft flew through these rings to make its orbital insertion maneuver around Saturn. And what we find is that the rings are not one large structure, but a whole bunch of little rings that are bound inside one another. The reason they're in this very, very tight formation is that Saturn's rings have little moons rotating around inside them called shepherd moons. And these shepherd moons use their gravity to herd the material into these very, very tight structures that we see today. Back in 2004, the Cassini spacecraft actually had to fly through this gap in the rings called the Cassini gap to make its orbital insertion maneuver around the planet. And in fact, these very pictures were sent back by the Cassini spaceship itself. The rings are a remnant of a comet that was flying past Saturn long ago. Saturn reached out with its gravity to try to grab hold of the comet and pull it into an orbit, like a moon. But because the comet was put together so lightly, it was so delicate, the tensional forces of Saturn's gravity ripped it apart to make these enormous rings that we see today. We're now going to leave Saturn and the gas giants. We're actually going to skip over Uranus and Neptune because we actually haven't sent a spaceship to those planets for a very long time.